All right, students. In the last video, we talked about the three forms of parabolas. In this video, we'll start with standard form, and we'll go over that one. And then each video will go through an example of each one. So today, right now, we'll do standard form. The standard form looks like this. We've talked about how to shift horizontal and vertical, but because of the form it's in, this is no longer a horizontal shift. What does stay the same, though, is A does determine if it opens down or opens up. And this is when A is negative, and this is when A is positive. That much has not changed. And by the way, when you read this, you have to read it as A is negative, and this is A is positive. That's how you want to sort of think about what that's saying. I know it says A less than 0, but what you're thinking is A is any negative number. And for this one, and A is any positive number. Okay, so the B and the C, what role do they play? Okay, well, it turns out the A and the B actually do play a role in what we call the line of symmetry. So every parabola has a line of symmetry, and what it is a line that goes right down through the middle. If I drew this perfectly, that would be going right through the vertex. Now, this is useful for a couple reasons. It tells us a lot about the shape of it, but also what we'll know is if we have a point here, we'll have an identical point here. If I'd drawn this on graph paper and I'd drawn it perfectly, this distance right here would be the same as this distance right there. Okay, they would be equal distances. So if I folded this, it should match perfectly. Now, the line of symmetry happens to be negative b over 2a. Okay. When we go into how to change forms on this, what we'll usually do is do completing the square. And it's hard to see where this formula comes in without completing a square, but that's going to be a separate video. So this is the rule. If you have values for this, you can find the line of symmetry, and then we can use this to find the vertex. Okay. So let's go and zoom out a little bit. I'll put the example right here and we'll run through with some actual numbers. For our first one, we'll just make A be 1 x squared plus 6x minus 3. We'll just make that one up. I really don't know what this one looks like. Okay. So there's our parabola. One thing I do know, just before I do anything else, because this is our leading term, we know it's a parabola because of the x squared. And we know it's upward because of the 1. So we sort of know what it looks like, we just don't know where it's located. Okay, that's what we know. This one is in the same family as this one, but because of the 6x and the minus 3, it gives it a different location. So the location of our symmetry would be this. X equals negative b over 2a. Well, we have a 6 instead of b. And instead of a, we had a 1. So negative 6 over 2 times 1, so negative 6 over 2, or negative 3. Let's simplify that. X equals negative 3 is our line of symmetry. Okay, got that cut off right there. Okay, that's very, very important. That tells us something right off the bat. Negative 3 tells us we're on the negative side of the graph. So when I'm graphing it, I don't need to draw a huge graph. I can put most of my emphasis on the negative side. So let's do that. So I've got my graph here, and I want to encourage you to always make it straight. If you have graph paper, then the spacing will be even, but you'll notice if my spacing is not even here, my parabola is not going to look perfect. Okay, the line of symmetry should be right in the middle, but if my numbers are off, it might not look perfect. The thing is, though, with graph paper, it would solve that problem. So what we have is, we know the, oh, wow, I just messed that up. I drew it nice and perfectly. Negative 3 was not supposed to be, negative 3 was our line of symmetry, and I put it at negative 2. Give me 1 second, I'll fix that. Okay, so I've redrawn it here, and there's my graph. Let me move it over to here. The problem is, the vertex is somewhere along this line of symmetry. We already said we know what shape it is, but we really don't know how low it is. Okay, I have no idea until we check it. Okay, so to do that, I'm going to take my original equation I'm going to make a table of values here. Now, I already know negative 3 is a vertex, so I'm going to put a little note there. We can plug in negative 3 and see what happens. And then we should go down and do negative 2, negative 1, and even 0. Okay. Sometimes the book will just ask for the vertex. Okay. And if you do that, you're fine. But with just the vertex, we still don't know the real shape. With a few more points, we'll get a really good look at the shape. So go ahead and take a second. You can use your calculator and try and fill those in. Now, we've got a number of negatives here, and you've got to be very, very careful. The negative 3 squared, that needs parentheses around it. So that's going to be a negative 3 squared plus 6 times negative 3 minus a 3. And we get a negative 12. So we know it's way, way down there. That's good. That tells us negative 12. I should have left myself more room here, but what that tells us is way, 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 way down here at negative 12. Okay. So 3 negative 12s. Negative 3, negative 12. Okay. And go ahead and take a second. You can fill in the other ones of these following the same method. Okay, so we know a couple key points here. Double check those. Make sure you got those values. And I'll graph this one. Again, I don't have graph paper, so it's going to be hard to fill in the other ones exactly. But as you fill them in, you would have gotten a very steep parabola like that. Okay. With negative 3, 0, 0, negative 3 right there. Negative 1, negative 8 would be down here somewhere. And negative 2, negative 11 would be right down there. So the more points you have, the more shape you can get. And again, if I'd done this perfectly on graph paper, the left side and the right side would match up perfectly. That would be right there. That would be right there. That would be right there. You have identical points on both sides. So that's the reason why we use the line of symmetry, and that's the method we're going to use for standard form. Thanks for watching.